Okay, on this one we have like this red curve. This drawing isn't really given to us, but with this red curve, we know that there's a tangent at 1 comma 4, and we want to know where that tangent, which is represented by the blue line, meets the curve again. So first we need to find the equation of the tangent line. And so to do that, to find the slope, we need to take the derivative. So 3x squared plus 1 is our derivative. We plug in 1. So that's just 3 plus 1. So our slope is 4 at that point. Then we use point slope to write our equation. So it's going to be y minus 4 equals 4 times x minus 1. Distribute, we have 4x minus 4, then add the 4 over here, so y is equal to 4x. That's the equation of the tangent line. And what we're going to do now, we're going to take this, set it equal to this to see where it intersects, and then we'll end up throwing out that answer because we already knew about that one. So when we do that, set them equal to each other, x cubed plus x plus 2 equals 4x, x cubed minus 3x plus 2 equals 0. Okay, now there's a couple ways we could approach this. We know it crosses at 1, so we could do synthetic division on this, and we could do, so we're thinking of this like x cubed plus 0x squared minus 3x plus 2 equals 0. So 1 is a root, because we know that was one of the things it's going to be divisible by. And then I write the coefficients here, so 1, 0, negative 3, 2. Bring down the 1, multiply, 1, multiply, negative 2, multiply, negative 2, 0. Remainder is 0, so that's good. And this will be x squared x constant. And so if we have x squared plus x minus 2, we can t-factor that. We want it to add up to 1. So we get x minus 1, x plus 2, and then the original one would have been an x minus 1 as well. And if we remember, this is all equal to 0 still. And so we could say that's going to be a 1, that's going to be a 1, that's going to be a negative 2. And so negative 2 is the one we didn't know about, because the original, we already had the 1. So negative 2 is the place where it meets the curve again, and so we go to the original right here, plug into negative 2, and we're going to get negative 8 minus 2 plus 2, which is negative 10 plus 2, which is negative 8. And so if we combine that x value of negative 2 and the y value of negative 8, that is the point where we meet the curve again. Okay, now we're given this. So it says find the equations of the tangents to this that pass through 1, 3. So we're going to just set this up as a, and then negative a squared plus a plus 2. So this is the equation of any point on the curve. Now, if we take the derivative of this to help us with the slope, dy dx is equal to negative 2x plus 1. And if we want to do it at point A, we're going to get negative 2a plus 1. And if we plug that into y minus y1 equals m, x minus x1, we're going to get y minus negative a squared plus a plus 2 is equal to negative 2a plus 1 times x minus a. And we can simplify that a little bit. So distribute the negative y plus a squared minus a minus 2. Distribute, we're going to get negative 2ax plus 2a squared plus x minus a. And then we'll continue with that. Let's get everything onto one side except for the y. Okay. So what we're going to do is just look at our slope and y-intercept essentially. So anything that has an x, I'm going to put here. Anything that doesn't have an x, I'll put right here. So negative 2a plus 1. These will combine to be just a single a squared. These cancel, and this is just plus 2. Okay, it's not too bad. Okay, now we know that the tangents that pass through 1, 3 must satisfy this, and so we're going to plug in a 1 and a 3 for these. So 3 is equal to negative 2a plus 1, x value is 1, a squared plus 2. Okay, the goal is just to solve for a. It's going to be quadratic though. Okay, multiplying by 1 doesn't do anything, so we can ignore that. And then if we simplify this, or just basically write it in a different order and combine these two, then we subtract 3 from both sides, we end up with 0 equals a squared minus 2a. And we can factor out an a. Set both pieces equal to 0. And a is equal to 2. Okay? And so we found these two a values that satisfy that. So if we come back up to this, we can use both those a values. So a equals 0 and a equals 2. That's what we're looking for. So if we plug in a 0, we're going to get y is equal to negative 2 times 0 plus 1 x plus 0 squared plus 2. So that goes away, that goes away. 1 times x is just x. So y equals x plus 2. That's the first one. Now if we plug in a 2, I'll do that over here. Y is equal to negative 2 times 2 plus 1 x plus 2 squared plus 2. 2 squared plus 2, so that's really a 4, so that's a 6. This is going to be negative 4. Combine that with a negative 3x. And so that is the equation of that tangent line. Alright, if you have additional questions, please come to MathLab. Until then, calculator.